you had a good weekend and ready to finish the good work we started this semester. We have this week and next week of studying, then we are going to do the culminating activity, which I don't want you to be worried about it at all. It will be a very simple activity that will cover everything we have learned, and it will be very easy, and it will not gonna be hard, or it is nothing to worry about. So just stay focused so we can finish this semester with all the knowledge that you need to know. Today we are going to learn about how to solve problems involving right triangles. So before I start, there is the two definitions that I want you to learn. Angle of depression, and what it means. Angle of depression, let's say we have a tree, something like this. And you are standing here. Okay? This is the horizontal from your eyes. The angle below the horizontal, so if you are looking at the bottom of the tree, this is called the angle of depression. This is the angle of depression. So it is measured with horizontal and below the horizontal, angle of depression. So this is my eyes, this is the horizontal. If I'm looking down, the angle that I make with the horizontal, my eyes make with the horizontal, is called the angle of depression. If I look up, also it is called the angle of declination, or if you look up, this is the angle of elevation, or angle of what else? Yeah, elevation. So this is theta here will be the angle of elevation. So angle of depression and angle of elevation, both of them measured with the horizontal line, and one is looking up and the other looks down. Okay, so this is the angle of depression and angle of elevation. Alright, this is the first thing I want you to know. Alright, so now let's have some, I'm going to give you two examples. Example 1. Okay, let us say we have two buildings, and the horizontal distance between them is 30 meters. There's two balconies here. So let's say we have a balcony here, somebody is here standing, and balcony here, other person standing here. Okay? And the angle of depression from this balcony to the bottom of this building is 40 degrees. So they say that this is 40 degrees. This is the angle of depression. Okay, and the angle of elevation from the balcony, this balcony, to this, to the other is two balconies. Let's say this is balcony A, this is balcony B. There is a guy standing here looking at the bottom, and they measure the angle of depression with the horizontal. It says 40 degrees, and he looks up to the other balcony, and the angle of elevation was 20 degrees. The distance between the two buildings are 30 meters. They need to know how high is balcony A and how high is balcony B. Okay? So, if I want to know, if I get this length from here to here, this length is how high balcony A, because those are two parallel lines, so if I get this, I can tell what is that. Alright? If this is 30, that means this horizontal line is also 30. And this is a right triangle because the building is making right triangle with the horizontal. Right? So now if we look at this triangle, right triangle, this one, 40 degrees, 30 meters. We need to find this side. What we do? Okay, what is given to me? Right triangle, so I can use SOHCAHTOA. Which trig ratio I'm going to use, sine, cosine, or tan? It depends what I know and what I need to find. I know this angle, I need to find its opposite, because this is across and not and adjacent, and I want the opposite, and I know the adjacent, which is the close by and not the hypotenuse. So it is very clear that I'm going to use tan. So I will say tan angle A equal the opposite, which is how high balcony A, so the opposite over hypotenuse, which is over adjacent, which is 30. So tan 40 equal how high the height of balcony A times 30. I just multiplied 30 in both sides. If I do so, I will get 30, 10, 40, and our calculator is in degree mode. So this is 25.2 meter. So the height of the balcony, so height of balcony A equals 25.2.17. So this height from here to here is 25.2. Okay. Now, if I want to find this, how high balcony B, so this is another right triangle. This is 30 as well. This angle is 20. And here we have angle A, and this is balcony B. And we need to find the opposite as well. So we can say tan 20 equal how high balcony B, opposite over adjacent. So the height, not height, the opposite will be 30, 10, 20, close bracket, hit enter. So this is the opposite. The opposite will be 10.9. So this is 10.9. That means from here to here is 10.9. Now if I need to find how high balcony B is, balcony B height equals 25.2 plus 10.9, which is think 37.1 meter. Okay, this is how we did this problem. Now let us work with 3D. So this is a 3D problem. We have a this is a right triangle. This angle is 90 degrees. It is on the ground, and there is another triangle. This is a 90 degree. Okay, this is 3D. Like you have here a cliff or something, and there is like a road here or some other thing. So this is a 75 meter, and this angle is 52, and we need to find the height of this cliff. This is y, so this is a road or something. This is y, this is x, and the measurement of this angle is 52 degrees, and the distance between x and y is 75, and this is a right triangle. So this is like 3D question. There is a road here, there is a cliff, and this is a triangle. This angle is 52, this distance is 75. We need to find how high is CF. So if we look at this right triangle, the one in the bottom over there, it is like this. This is C, this is X, this is Y. This is a right triangle, this is 75, this is 52. So if I use tan 52, that will equal opposite, which is CX, over the adjacent, which is 75. So CX, the measurement of CX is 75 tan 52. I can get that using the calculator. 75 tan 52, enter. So this is 95.9. So I can say this is 96. Now in this, I want to find this one, so I can draw this triangle. I have here XC, which I found, that's 96. I have here, this is 90 degree, and the angle of elevation here, this is 61 degrees, this angle is 61. So I can find CF. The angle of elevation from here to here is 61. So CF, let's say tan 61 equal CF over 96. So CF equal 96 tan 61. Hit enter. 173.2 meter. So we found the height of the cliff, 173.2 meter at the end. So this is how we work with 3D. Alright, I'm going to post this on XP, and I will give you some homework. Tomorrow we're going to have an assignment, then we're going to learn how to solve a triangle that's not a right triangle. Okay, have a wonderful day.